So I want to talk about forms of a quadratic function, and we'll start with a form you're probably familiar with called standard form. Standard form is kind of how you're used to seeing a quadratic, like f of x is equal to negative 2x squared plus 8x plus 10. Or you might have heard this talked about as f of x is ax squared plus bx plus c. And standard form is used all the time for solving quadratics, and it's just kind of the simplest way to see a quadratic. But it's actually not ideal for some uses. So for example, if you want to solve for the zeros or the roots of a quadratic function, that's when my outputs are zero. That's what that terminology means. My outputs are zero, that's also my x-intercepts. So I might be looking for x-intercepts, or I might want to know when this equals zero because that'll tell me something about a model. Well, if I just started with a quadratic that I had some equation I was solving, my first step would be to put it in standard form, which we already have right here. My next step, honestly, should always be to try to factor because that's the fastest way to see the zeros, and I'll show you that. And then if that doesn't work, then I would use the quadratic formula, because the quadratic formula always works even when my zeros are complex. So we're going to find the zeros, though, by trying to factor, or the x-intercept. So if I'm looking for when my output is zero, that's when negative 2x squared plus 8x plus 10 is equal to zero. The first thing I can do is I can factor a negative 2 out of the whole equation. So if I factor a negative 2 out of negative 2x squared, I'm left with x squared. If I factor a negative 2 out of the 8x, I'm left with negative 4x. And if I factor a negative 2 out of the 10, I'm left with negative 5. My next step is to try to factor this quadratic into two factors. So I'm looking for something that when I FOIL, my last will multiply to negative 5. So I want it to multiply to negative 5, but then they'll add to negative 4. So there's not very many multiples to negative 5. My options are 5 and 1. For that to add to negative 4, I need a negative 5 plus 1. So when I FOIL, this works out. So 0 equals negative 2x minus 5, x plus 1 is my equation. Now for this to be 0, either x minus 5 is going to be 0 or x plus 1 is going to be 0. Because if they're both non-zero, they'll multiply to something non-zero. Which means my equation becomes x minus 5 equals 0. Add 5 to both sides tells me x is 5. Or x plus 1 equals 0. Subtract 1 from both sides tells me x is negative 1. So my zeros are x is 5 and negative 1. Well, this brings me to what we'll call the factored form of a quadratic. So notice I could just read those zeros off. If I had taken my standard form, f of x equals negative 2x squared plus 8x plus 10, and then I factored it, we call this factored form, and I can just read my zeros off that equation. So in general, factored form looks like a times x minus m times x minus n, where x minus m and x minus n are my factors, and I can read my zeros off from my factors. So factored form is super useful, and if I'm going to graph my quadratic, I can see that, hey, I have an x-intercept at 5 and negative 1. Since my coefficient, my leading coefficient is negative, this parabola opens down. So I can sketch a quick graph of this quadratic. The only thing I don't know is how high this goes, this vertex. So my factored form gives me a nice graph that's a quick and easy graph of my quadratic. But I don't know the vertex, and that brings us to another form that we care about. So sometimes what we want is we want to solve for when our quadratic function is max or min. So in this case, when it's an upside down parabola, it would be looking for when it's maxed. So like maybe if I wanted to maximize a profit function, or if it was a right side up parabola that opened up, I might be looking for the min. And if I want to find a max or min in an application, what I'm really looking for is the vertex of my parabola. So going back to my original equation, after we factored the negative 2 out, I had x squared minus 4x minus 5. You might remember from Math 95 or from intermediate algebra, there's a process called completing the square. We're not going to go into detail on that, but essentially, if I were going to complete the square, I would want to add and subtract something that would make this a perfect square. In this case, my b is negative 4. I divide that by 2, negative 2, square that, I'd get 4. So in this case, I'm going to add and subtract 4. Now when I do that, this piece here is a perfect square. It's x minus 2 squared. So I get x minus 2 squared, and I still have minus 4 minus 5, so that's all minus 9, which gives me negative 2x minus 2 squared. If I distribute the negative 2, I get plus 18. And this is called vertex form of a quadratic. So vertex form looks like f of x is equal to negative 2x minus 2 squared plus 18, or f of x is equal to negative 2, or sorry, a x minus h squared plus k. And the reason this is called vertex form is if we remember from transformations, if I were going to sketch a quick graph of this function and I work inside out, I'd see that first I shifted my regular quadratic to the right by 2. First I shifted it right, then I flipped it over the axis and did a vertical stretch by negative 2, and then last I shifted it up 18. So I went right by 2 and up 18, and then somewhere in there I also had a vertical stretch. So the 2 and the 18 tell me where my vertex winds up. And so this is called vertex form because HK is my vertex. Now, we found this vertex by completing the square, but we can do this with a cheat. So I can always find my vertex by saying h is, from standard form, by saying h is negative b over 2a, and then k is just the output at that vertex. So k is the output at negative b over 2a. So that gives us 3 forms of a quadratic. We have our standard form, which we're used to. F of x is ax squared plus bx plus c. But if I want to solve for zeros or roots, then I might go to factored form. F of x is a times x minus n times x minus n. And I can just read the zeros off. If I want my vertex or my max or min, I'll go to vertex form. F of x is a times x minus h squared plus k. And I can just solve for my vertex. Of course, I can always get from my vertex form back to standard form just by FOILing. Multiply this out, or from factored form back to standard form just by FOILing and multiplying this out. And those are three forms of a quadratic.